I am Roshan Basnet, bearing roll number 20NS0308 of Physics Department, Sikkim Government College, Namchi. Firstly, I would like to express my gratitude to the Department of Physics and my teachers who gave me this golden opportunity to do this wonderful project on the topic STM and AFM. Any instrument that can be used to magnify an object is simply a microscope. It is hard to say who invented the first microscope because people were probably playing with magnifying lens ever since clear glass was invented. But the first compound microscope was invented in 1590 by a Dutch eyeglass maker. In 1665, Robert Hooke discovered plant cell while studying cork shell of a plant. In 1674, Antony van Leeuwenhoek observed protozoa for the first time, and several years later bacteria. He called them animalcules. All the microscopes we talked till now were all light or optical microscope. Microscopes that bends light to magnify an image of an object are light or optical microscopes. This type of instrument can have magnification of around 1500 times and limit of resolution from 200 to 250 nanometers. To put it simply, they are powerful enough to see cells, bacteria, protozoans, but not powerful enough to see atoms, molecules, and even many viruses. In 1931, Ernst Ruska and Max Knoll invented the first ever working electron microscope. Unlike light microscope, it uses electron beam instead of light to magnify an object, and the image is generated by computers. In 1980s, new way of seeing was invented, scanning probe microscope. They see by feeling the bumps of an object with a tiny metal probe. Data collected from the probe as it scans is used to generate extremely high resolution image. Scanning tunneling microscope. STM senses the surface by using an extremely sharp conducting tip that is 1 atom thick. The metal tip and the sample is separated by a very small distance of few angstrom in vacuum. Bias voltage is applied to the metal tip and the sample, which allows the electrons to flow from the metal tip to the sample. The information acquired by the flow of the current is used to make a high resolution image. It has two modes of operation. Constant current. The tunneling current in the tip is inversely proportional to the distance between the tip and the sample. So to keep the current constant, the tip moves up and down, keeping the distance between the tip and the sample constant while scanning. The information on the motion of the tip is used to generate the image. Constant height. When the height is kept constant, the distance between the sample and the tip varies, and therefore the current between them also varies. The information on the variation on the current is used to generate image. Limitations of STM. It is very difficult to use. The sample must be conducting. Atomic force microscope. In atomic force microscopes, the tip of the cantilever is contacted with the sample. When the cantilever moves for scanning the sample, the tip of the cantilever moves up and down, resulting in the deflection of the laser beam by cantilever, which is further detected by photodiodes. Based on the information of the photodiode, a high-resolution image of the surface is created. Limitations of AFM. Scanning height and area is limited to micrometers. Scanning speed of AFM is low. Again.